Hey, what's happening, everyone? So hopefully the sound's working. Don't know. I don't have my headphones right now. We're going to find out later, I suppose. Three pair of corresponding sides are proportional in two triangles. So three sides, letter D, definitely going to be that one over there. Polygons with exactly the same shape. That's our definition of a similar polygon. Two pairs of corresponding sides are proportional and their angles are congruent in two triangles. So two sides and one angle, so it's SAS. So that's going to be letter E. Two pair of corresponding angles are congruent in two different triangles. That is two different angles, letter C. And number 5, the ratio of corresponding sides in similar polygons is our scale factor. Let's just go ahead and move right in past the vocabulary, the center of dilation. You're going to connect letters. Connect the same letters, really, I should say. And where they meet is going to be your center. Meet equals center. I'm pretty sure for every single question that we've done so far, the center for these has been 0, 0. Not really sure why all the questions have had that. But if we just go ahead and start drawing it over here, and I'm sorry for the zooming in and out. We're going to try to fix that permanently. Hopefully that fixed it. And then now we're going to go ahead and connect the letters. There's that letter B to this letter B, and we're going to connect them, and we're going to draw that line. We're going to do the same exact thing for A and A prime. We're going to draw that line, and then C and C prime. We're going to draw that line. If you notice, they all meet at 0, 0, just like we thought. But that is how you do it. You draw the lines to it. I don't know if it's going to change for anything in the future, but that's how it is. To find the scale factor for any dilation, by definition, scale factor is going to be the ratio of the new to the old. Basically, you're trying to figure out the old multiplied by k is going to be the new, or in other words, if I divide both sides by old there, the k is going to be the new divided by the old. For this particular question, it's going to be easiest if you could just figure out a single coordinate and then move them around as is appropriate. So for instance, I'm going to use letter B and I'm going to use the y values. So the old value, our letter B, let's do this. You know what? I'm going to change color just to make sure it's super clear. For this letter B here is going to be 0, 1, 2, 3, 0, 3. And then B prime, that's going to be 0, 1. Remember that prime means it's the new one. So in this problem, our new over old is going to be 1 over 3. That also makes sense because a scale factor that is below 1, that's a fraction, is going to make it smaller. And a scale factor that's above 1, if it was like 3, then make it bigger. And our new one is smaller, in fact. All right, so which of these describes the dilation? So we just talked about how it's smaller, so that's going to be reduction. So it's going to be a reduction, and it always has parallel sides. The perpendicular side doesn't make any sense whatsoever. Remember that perpendicular means creates a right angle. There are no right angles over there. Our parallel sides, that's exactly what happens with every single dilation by definition. Let's check out the next one. Which of these is proportional in both of these triangles? So it turns out that actually there are two correct answers to this problem. It's going to be side lengths, and then area is like technically true. However, it's the square is proportional. So what am I talking about? Like if I just take the side lengths here, like this length of this exact one is going to be 1, 2, 3, 4, 5, 6. So the big one is 6. So the old had a length of 6, and the new one has a length of, looks like 2. And if we notice, it's that divided by 3, that the 6 times that 1/3 that we learned earlier was 2. However, if we found the areas, these would also be that way, but it's going to have a ratio of a 1/9 instead. So let's check that out really quick. This is like bonus material. You can skip ahead if you're trying to figure out just answers to this thing. So our area of our triangle, which we haven't even talked about at all this whole year, which I'm kind of surprised, honestly, is 1/2 times the base times the height. We just figured out the base was 6. And the overall height would be, looks like 1, 2, 3, 4, 5, 6, also 6. And that's going to be 6 times 6 divided by 2 is 18. And then the area of the tiny triangle, which I'm going to draw with a little tiny baby going like that, is going to be 1/2, and then it's times 2, which is exactly 2. So if you notice, the ratio here is going to be 9, like 1/9, and that's because it's area, and areas are squared. So anyways, there's that extra information for you for those who care. Number 10, which of these is the same length in both triangles ABC and triangle? The only thing is they're the same are going to be angle measures every single time. That's our definition, is that for dilations, changing size does not change the angle measure. Let's check out the next page here. Which of these describes a sequence that maps this trapezoid to this trapezoid? So we're doing from ABC to AEGF. So looking at it, it's becoming bigger, and it looks like it's been flipped upside down. So flipping upside down, also called a reflection. So let's see, we need to dilate for sure. So A and B are both wrong because they don't have a dilate. It looks like we need to multiply it by 2, so it's got to be right here. There's that reflection we talked about, and sure enough, so remember that reflection's flipping upside down. Is it just flipped upside down? Yeah, just making bigger and flipped upside down, right? Yeah. So rotating 180, not quite the same, but there it is, whatever. Here we go. Are the triangles similar by angle, angle, side, 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 or not similar? So to check which one it is, it looks like we have all the sides listed. But we do need to actually check to see if they are actually similar. So it's definitely not angle, angle, or side, angle, side, because we don't have the angles listed. We only have the sides. But let's actually compare and contrast. We need to do, I'm going to do the shortest side over the shortest side, so 4 divided by 6. We need to verify that that is actually going to be the same as our other sides. So for instance, we have the short over the short, we're going to have the medium over the medium, and then we're going to have the long over the long. Checking on our calculators here, this one here is 2/3. And again, you can just divide both of them by 2, or you could use your calculator, your alpha y equals enter on that calculator if you wanted to. The 10 over 12, that's the same thing as 5 over 6, and this guy here, the 10 over the 15, is 2 over 3. But if you notice, this one is a problem. It is not exactly the same, so the answer is not similar because they are just not the same. They need to be all equal to each other. Are the triangles here similar? So if they are similar to each other, it's guaranteed to be the side, angle, and the side. So it's not going to be side, 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 or angle, angle, but we do need to verify that the lengths are correct. So we're going to go ahead and do the long over the long, and that's going to have to equal the shorter over the shorter. So 10 over, oops, I just said 10 and I wrote down 20, 10 over 25. So again, I did the longer length over the longer length, and then divided by and equal to the 10 over the 25, the shorter over the shorter. 15 over 33, again, use your alpha y equals enter to reduce it, or you could just recognize that both divisible by 3. So if they both divide by 3, we're going to get 5 over 11. And then we're going to do 10 over 25. And if we have a 10 over 25, we're going to have a 2 divided by 5. Those are not the same as each other. So again, not similar. I'm going to pause really quick. Okay, so I paused recording because I figured they weren't going to give us 2 incorrect answers in a row, and I was definitely right. So I made a mistake on number 12 just by glancing back over it. I used the number 10 twice. I forgot to use the number 8. So this 10, in fact, should have been an 8. And 8 over 12 is 2/3, which means the correct answer is, in fact, similar to each other. So if you caught that before I did it, feel good about yourself. But yeah, in fact, it's going to be our side, side, side similarity is correct because it is 2/3, and I made a mistake. I did not make a mistake on number 13, though. I double checked that one is right. This one, this fourth one here, if 2 angles are the same, they're automatically similar. There are no numbers to check, which is nice and easy. Question number 15, for this one, you will need to check our side, angle, side situation. We have the angle and the side, the side, the side, the side, and it's a right angle. For those who have been paying attention in previous videos, you might notice this is a 3, 4, 5 triangle, and this is also a 3, 4, 5 triangle, a 6, 8, 10. But if you wanted to verify it, we could do the longer side over that longer side is going to be equal to the shorter side over the shorter side, and that does equal a half for both of them. So we are good to go there. Let's go ahead and do our very last page here, number 16. So we need to use these similar trapezoids to figure out which one is actually correct. On the actual test, I did fix the wording of what this says up here, but it's not quite two similar trapezoids just like that. We had like the correct lettering for it. So just so we know, it's going to be saying that A, B, C, D, is similar to E, F, G, H. I made sure they actually word that correctly in the test. That way we can actually set these up, but we want to make sure that we have the side over the side. So we notice that the AB over the EF is going to work. So we have AB over EF, and the idea is these two letters and these two letters line up. So we're going to have x plus 3 divided by x minus 1, the AB over the EF. And then now we're going to go ahead and get the 6. And that's going to be over the only number that's left, 3. By the way, another acceptable way to set this one up might have been like number over like the longer side. So we could see that it's like the long over the short. So maybe you could do like 6 over x plus 3, and then long over the short, 3 over x minus 1. Regardless of what you do, though, after this, you're going to have to cross multiply. So you're going to cross multiply, multiplying up here, and when you do that, you're going to put it around parentheses. So I skip the work oftentimes in class, but I'm going to show every little step here just in case you need it. Now we're going to distribute this 3 to both, we get 3x plus 9. Distribute this 6 to both, we get 6x minus 6. And then last but not least, we need to make sure we're solving it just like a regular old equation, kind of drawing that line down the middle. We're going to go ahead and move the 3x to the other side, the 6 over here, so it's going to become a 6 plus 9 is equal to 6x minus 3x. 15 equals 3x. X is equal to 5. Easy enough. Let's continue on. What is the value of x here? So it doesn't, it does say y in a second. So looking at the value of x, this is going to be our proportional. They are similar triangles. I suppose we didn't need to draw any letters for this one, but we can just say that x over 9, so I'm using that left-hand triangle over the right-hand triangle over here. So we're going to have the 10 over 15. And the fastest way to solve this question is just going to be to multiply both sides by 9. So that's what we're going to do. We're going to go ahead and multiply both sides by 9. I'm going to really show the work all the way out here on mine. And if you throw that into your calculator, you'll get the right answer. You can also cross multiply by like 9 times 10 and 15 up here. Regardless what you do, you're going to get 6. By the way, if you want to know how I did that in my head, cute little trick. 10 is divisible by 5. 15 is divisible by 5, so it's 2 over 3. 9 is divisible by 3. 9 divided by 3 is 3. And 2 times 3 is 6. There's how I did that one. And what is the value of y? Well, really, this one we know is going to be 34 degrees. And we have a 90 minus 34, so y is equal to 90 minus 34. No extra bonus stuff for that one. Just a straightforward answer of 56 degrees. Maybe not even the degree symbol, because it's just not even, it's just what y is, right? Y already has that degree symbol, so just 56. All right, we only have 2 more problems left. What is the value of x here? So again, they're similar triangles, and angles are always equal to each other. So we can just set this up. 2x plus 14 is equal to 50. We're going to move that 14 to the other side, showing all the work here. Again, you don't need to show nearly this much work on these problems. Equals 36. Divide both sides by 2, and you're going to get 18. And then finally, our value of y. We do need to be a little bit careful on this one because the y is in that little tiny short section. So for this particular problem, the way that we're going to do it, we're going to do 15 plus y, so that's like the longest side of that figure, divided by 15. So we had long over short is equal to long over short is equal to 12 over 9. We're going to need to go ahead and do our cross multiplying just like we did before and showing all of the work. 15 plus y is equal to 12 times 15. 9 times 15 there is 135, plus 9 times y is 9y. 12 times 15, that's going to be 180. And then we're going to go ahead and do our subtracting 135 on both sides, kind of doing it up and down this time. 9y equal 45, divide both sides by 9, and finally, y is equal to 5. Have a wonderful rest of your day, guys, and peace out.